First one, you are welcome to the True Word channel. The True Word channel is a YouTube channel that brings to you the truth, nothing but the truth. Now, today, I want to talk about construction and a certain technology or method which our brothers or some of our brothers adopt into the system, whereby they use polythene to fight underground water. I am Eric Paddy Boso. Now, when we go to some of our big cities across the world, we'll find out that a lot of structures or buildings have been existing for so many years. Some have been there for centuries, but they are not affected by underground water and dam and also the wetness that we experience in some of our new buildings, especially in the developing areas or countries across us. Now, these structures, which are in the big cities, have a lot of treatments or the technologies used from the foundation stage are very unique. As such, their way of fighting underground water is more advanced than what we have today. Some of them use treatments, some also use polythene, but in the right way. I invite you all, the contractors, the engineers, structural engineers, architects, builders, and so on, to take notice of this so that we'll be able to have good work for our employers. We have to think not only about the profit that we will make by constructing a project to a client or a customer, but we must also consider the fact that it is their hard-earned money, and such monies are not earned easily. So we need to adopt the right strategies, the right plans, the right method to be able to deliver the projects to high standards so that they can have more benefit and value for the money that they have invested. Although this strategy of fighting underground water may have a little bit cost to the estimation, but then house owners must also agree with us so that we'll be able to come out with very sustainable methods, clothing that will be able to fight underground water. In fact, when you go to certain houses, you see the way the outside, especially the peeling off of the paint, the warning out of the plastering, and then also the way the floor is wet, it's always devastating. And we need to do something to the way we approach the foundations of our houses. On this note, I'd like to get to the board, join me, be with me, so we get deeper into how to create the footings or the foundations of our buildings in order that the buildings will have long life, so that the monies we put into it and the efforts we put into it will not be just for the short term, but will also serve us for a long period. So now let's get to the board. Now, under construction, my main focus will be on the use of polythene. Now, the use of polythene is not a bad idea, but then the way we use it can have positive or negative effects on our building structures. Now, let's say this is our ground. So we have underground water. Now, every type of soil or land that we may come across to develop, some way, somehow, there is presence of underground water. If there is no presence of underground water, there might be presence of certain chemicals inside the soil. This underground water is not an ordinary water, or the chemicals present in the soil might not be ordinary chemicals, but mostly acidic salts. These acidic salts have a lot of effects, especially on any structure we put into the soil. Now, this soil can be cleaned, it can be sandy, it can be gravel, and then it can also be a mixture of all this, or sometimes loam. We encounter these different types of soil, and these soils do not or cannot escape the presence of chemicals from the underground, be it loamy, gravel, sandy, or clay. They all contain certain type of chemicals that fight our buildings. Now, the method our builders are using, which I think or I did not share the same idea with them, is the use of polythene to cover the surface of the footing. So with the diagram, it goes like this. Let's say this is our footing work. Now, this, is a block work. Now, after our brothers build, or some of our brothers build this footing for a house. Let's say this is the house. This is the house. This is the footing of the house. When they introduce the polythene material, so this is the polythene material in between the footing. This is the polythene material in between the footing. So over here, let's say this is our footing. So this is our footing. And then this is our floor concrete. So they introduce this polythene material in between the foundation, the floor concrete, and then the footing. In other words, they lay the material, the polythene material here before casting the floor concrete on top of it before building the house, erecting the house on top of it. This strategy or this method of fighting underground water is wrong. It's very wrong because it's not all the underground waters that walk through the concrete, through the block work, and appears here. Most of it uses the side of the block, both in and out, to get to the floor level. So putting the polythene here on top of the floor has a lot of problems for the lifespan of the building. And we all know that the foundation is the building. So more concentration must be done here. Now, this technology has completely disconnected the floor concrete of the house or the base of the house to the foundation. And we know that when the house is built, it takes time and settles. And when it is settling, we know that because of the columns here, maybe there may be columns here. This side of the house will settle, and then over here will also settle. At the center, the base of the house will not settle at the same rate as switch here and then the end which is connected by the iron bar will be settled. By so doing, there's going to be a disconnection between the floor of the house and then the footing of the foundation of the house. If this happens, there's going to be a gap, irrespective of plastering. There's going to be a gap in between or surrounding this polythene material that separates the footing from the floor concrete. So if this happens, this gap, eventually there's going to be a crack where air will pass, find a way to enter. Air occupies this space. And the moment air gets access to get into the gap between the floor concrete and the footing, which is separated by the polythene, it begins to open a space. Now, another thing is when it breaks, comes out, the cat comes out here, ants and insects begin to live inside these gaps. Another thing is anytime there is a flood, since there is a gap there, this water forces itself to enter into these gaps. Then another thing is every house has its own load before other loads, especially wind. When wind is coming in any direction and pushing the building back and forth, wind has the capacity to go to push the house on to and fro. When that happens, because of the disconnection between the foundation, the footing, and the house moves differently, while the foundation also moves differently. Another thing, if there is an underground water that is flowing in a horizontal direction, it also affects the footing. And so it moves the footing and shakes it a little bit. But then, because of the disconnection, it doesn't move the building in the same rate. Then, another thing is earthquakes. In earthquake prone zones, or where the grounds are not always stable, the foundation has the right or have uh, the chance to move. And mostly, the building is more heavier in weight than the foundation. So anytime there is a shaking or there's an earthquake, this foundation find it difficult to support the weight of the building because there's a disconnection. And the only thing is the ions here that support the building. And since the weight of the building is heavier than the foundation, there's going to be a disruption. And this can also lead to cracks in the wall. So this technology of using polythene to support to prevent groundwater is not the best. Now, how do we build our houses and structures to be able to withstand underground water? So let's come here. One, let's say this is our trench. This is our trench, the foundation that we dig to be able to start the footing. Instead of putting the polythene on the top of building the wall and putting the polythene on the top of the wall, we put the polythene over here. So over here we have polythene. Now, if it is a clay soil, then there is a possibility that there will be cracks under the foundation. And so before we place polythene, we fill the foundation first of all with sandy soil. This sandy soil prevents the cracks from attacking the concrete, the foundation concrete directly. Anytime the soil or the clay soil becomes dehydrated and begin to open, the soil we place here automatically fills into the gaps, to the cracks. So the crack does not affect the foundation concrete. That also, when the soil under the foundation concrete becomes so dry, maybe it is just a clay soil, and becomes so dry and it needs more water, it doesn't drain more water from the foundation concrete because the concrete don't have only have to be dried, but must also be uh, hydrated. The dry concrete that are putting the house, the foundation must be hydrated. So that is how we treat it down, especially when it is clay. Now we lay our polythene material here inside a trench. Then now we have our foundation concrete. This foundation concrete must be very thick, at least 8 inches to 1 foot thick. This concrete shouldn't just be a plain concrete. We can have aqua stoppers, admixtures, improved materials, improved cements to add to the concrete. And also, we must make sure that the mixture, the ratio is 1 is to 2. That's cement is to sand. With this mixture, it makes the concrete very rich. And then with the presence of the admixtures, it makes the concrete very, very sticky. And it will be able to withstand the acidic waters and the acidic salts that are present in the underground water. Now, after we cast the concrete, we also have to lay our block work. So let's say this is our block work. This block work, we must make sure that we use 6 inches blocks. Even if it is a small house, use 6 inches blocks. 6 inches blocks are more robust, they are more stronger, and they will be able to withstand more of the effect from the underground waters than 5 inches or 4 inches blocks. So it should be 6 inches solid blocks. These 6 inches solid blocks must also be made from a high quality cement. The quality of the block must be very solid. There should be admixtures such as aqua stoppers and waterproof material added to the blocks before it's being manufactured. Now, the mortar which to be used to connect the block should also be very rich. The same admixtures and aqua stoppers will be added to the mortar to be able to lay the blocks. It makes the mortar very sticky, and also when it dries, it becomes very hard or too hard for underground waters to be able to corrode easily. And the next thing is you must use a very good workman. The masons that are going to lay the blocks, you must make sure that they are highly qualified because the gaps between the blocks, the mortar joints, shouldn't be open. They must be well sealed and also well rubbed so that air and water cannot easily penetrate into the joints of the blockwork. Now, in any case, some people may use the same sand that is collected from the excavation for the ceiling to fill the foundation inside the blocks. Some people may also collect all the excavated sand away and bring in a laterite or a sandy soil to fill or a gravel to fill these gaps. It's a good idea. Some people may also use or apply a damp-proof paint. It's also okay. You have to apply damp-proof paint on the wall, both in and out, before filling it. It's also acceptable. Now, after filling it, you make sure you compact it very, very well. After the block work, you make sure that the block work dry to extent or obtain certain level of maximum strength so that during compaction it doesn't move. So after you compact and it is settled, then now you can put your floor concrete. Now this floor concrete will have direct contact on the block work. not as it is here. This block concrete must have direct contact with the blockwork. Now, you can still use the polythene over here if you wish to. If you feel that the groundwater can still rise from somewhere here into to getting the floor concrete wet or moisture, then you can still use the polythene over here before the filling, or after you finish the filling, you put it on top of the filling, but not, you make sure it only occupies this gap, but does not get to the on top of the block. So you put it in between here before you lay the floor concrete. That is an area where there is the underground water is very heavy. You can still put your polythene over here, but not on top of the blocks, because the floor concrete needs to have direct contact with the blockwork so that there's a unison here. So anytime the building is about to sink, it moves with unison. This does not dissociate from that. Now, by doing so, or after this, now you can raise the top structures or the superstructures on the building, and then build as much as you want to build. This is a technology that is adopted for so many years and is being used to protect buildings in both swampy areas, areas that we have a lot of chemicals underground, and then also around coastal areas where we have a lot of salt in the ground. Now, when we do we adopt this strategy, in some years to come, there's going to be a crack, a, a gap over here, and therefore, when there's flood, we should know that our house can, the foundation of the house can easily be washed away. When there's an earthquake, the foundation can crack or the main building itself can crack, and there's no direct contact, as in this case. So we must take note. Although this may pose a little bit pressure in terms of money on the estimation, we need a little more money to be able to meet these demands. But then our concentration shouldn't be, especially when we want to build a house, our concentration shouldn't be on how to decorate the house and what to use to stock the house. The concentration should rather be on the foundation, because you can have a nice house, standing looking beautiful. When you enter, it looks very nice, nice ceilings, nice walls, but the foundation, the inside and the outside of the house is peeling off. It's stopping. The salt is stopping it in a way that it is running out even to the core of the block. Such houses do not have life. After a long time of working and saving, if you want to build a house, you don't have to build a trap for ourselves. We need to build something very sustainable so that when we grow, we can still have benefits for our projects at least 50 years before there will be a major renovation, because the ratio of concrete that we use for the foundation and also for everything here on the footing, it is quality. When you go to our big cities, some of the houses and the structures we have, they are not built with easy cement or concrete. The concrete are very solid. The mortar is very solid. So such houses, although may have more capital intensity from the beginning, but it pays off as the years pass by. So now we come to how this underground water can be treated, or the buildings can be put in a way that underground water may not have effect or much effect on our buildings, causing the damp, the mold, the wetness of our floors, and so on. So this brings us to the end. Let's take a look at the major points. So moving away from this method, we are saying that we apply to one, we apply we apply the quality inside the trench before the foundation concrete. This is number one. Instead of building the footing and then lay the polythene on top of the footing, we rather apply the polythene inside the trenches before we cast the foundation concrete. And number two, if there is any, if it is a clay soil which can always crack and expand, then we have to fill the trenches with sandy soil. If there is clay detected at the bottom of the trench, of the trenches, it may happen that we may have a clay. So if we have it, then we have to pour or fill the foundation trench with a little bit of sand, at least maybe 4 inches thick, before we put the polythene back. But sometimes it may not be a clay, it may be normal sand, it could be a gravel or loamy soil. Yes. But if there is a clay soil, we mostly have to fill it with a sandy soil before we go ahead and lay the policy. Now, number three, mix the concrete with aqua stoppers or with damp proof cement. So the foundation concrete must be mixed with either an aqua stoppers or damp proof cement. Number four, the concrete that we are casting into the foundation trenches must be very rich. So the concrete must have a mix of a mixed ratio of 1:2. Thus, cement is to sand. You must have this ratio. One part of cement, two parts of the same quantity of cement for the soil. And then also you must add admixtures to the concrete as we propose to make sure that the concrete becomes very sticky and solid. Number five, the water we need to use must also be tested. Now, we are running away from soil and acidic contents. It is very, very easy that we use water that also contains this kind of chemical. So our attempt of running away from underground water might not be met because of the water we use to mix the concrete. So in this case, the water we use should be clean and free from chemicals. That's water. The water must be clean and free from chemicals so that we'll be able to escape completely from the presence of these chemicals. Then number six, the mortar must also be very rich, at least 1:2 ratio. The same ratio we have for the concrete. We have the same ratio for cement and sand so that we can have the same strength for the mortar joint. Don't forget the block must be 6 inches blocks must be 6 inch thick solid blocks. And these blocks must be manufactured from, or during the manufacturing, they must add admixtures or chemicals that are anti-fungal so that they'll be able to fight, the, withstand the fight against underground waters. So the block must be 6 inch thick and then must also be rich and then must also contain chemicals which will be able to fight fungus. Number 8, then the wet one. You must use a very good workman, the mason who is going to arrange or lay the blocks must make sure that you use a correct workman so that he's able to fill all the holes in the wall. Rub it very well, make sure all the holes are filled because the foundation, you are not going to plaster it. The foundation is buried into the soil. You are not plastering the foundation. So the foundation must be sealed so that water and air does not have access into the inner hole, into the water joints. It's very important. Then number 9, we can we can apply damp-proof paint on the wall surfaces before sealing. Some people can choose to apply damp-proof paint on the walls of the footing before sealing. Then number 10, some people must also use sandy soil or a different soil, such as light or gravel to kill the footing. So some people can use different types of soil to fill the footing or in between and outside the footing, or you can use a sandy soil to fill it. Then after filling we have compacting. Make sure we compact the filling inside and outside. That is after the block work has dried and have the maximum strength, we can now compact and make sure that it is very stable. Because by digging the footing, the foundation, we have disorganized the formation of the soil by excavating the trenches. So after we finish, we don't just pour the sand to till it and leave it, but we compact it so that the soil become more strong, just as it was originally. And by so doing, it gives the building a very strong and organized footing to stand on. So compacting is very, very important. Then now we can cast our floor concrete. But after the floor concrete, we can erect our building to any height that we want. This will put, just as I said, to put a little bit pressure on the estimation because it needs more money to be able to meet these demands. And as I said, our concentration shouldn't be on how to finish the house, how to furnish the house, but our concentration should be on the foundation. What type of foundation are we building? When we employ the service of geotechnical engineers, they may propose that this type of foundation is good for this type of soil. But then still, without treating the foundation very, very well, and the footing very, very well, we will not be able to fight underground waters. When you go out to buy houses, there are some houses that they build, people build to sell. When you go out to buy those houses, you find out that within some short years, the footing and then the ground begin to get wet, mold begin to grow all over, and then also the blocks and the plastering begin to run out, the paint begin to peel off. All this because underground water has not been taken proper notice of before erecting the structures. So just as I have illustrated, when you go by that, your structure will be very strong. You can continue with the 1:2 ratio of the use of cement and sand in all over the body, and you find out that your body becomes very solid, especially those at the coastal areas and then swampy areas because some of the underground waters can try to walk all over to about 4 feet on the surface of the ground. So there is need to continue with the solid and the mixtures and the treatment to give to the underground. The concrete, we should continue it up to the high level. In certain cases, some people build the footing or the foundation very strongly and then they do anything to this, the wall itself. They reduce the quality of cement in the treatment. What happens is that during rainfall, rain also contains certain chemicals in the atmosphere. So when rain falls, it also hits directly to the building surfaces. And when it does so, it also contains chemicals that can also eat into the painting, into the plastering, and make the blocks very, very weak. So building will not be just put anyhow. If you want to build to be able to stand atmospheric pressures and also be able to have a long-term benefits and the value for our money. And even we, the contractors ourselves, we should be able to be proud that we are able to keep up a building that was or is able to withstand for at least 50 to 60 years before major renovation, then we need to be very careful on how we use these materials. It will cost anyway, but when we do it, it will take us a long way. Thank you very much. I want you to like, I want you to share with friends and builders across the world. I strongly recommend this formula, this method for fighting underground water. It has been something I've used for so many years, and it has proven to be good, and it has always given me the confidence when I am constructing a project for my clients. I've never worked anywhere we found out that the grounds are wobbling. No, all my foundations are always solid. Thank you very much, and I hope we'll meet again so that we can learn more about how to invest into our building in order to get the needed benefits we need. Thank you very much.